Today we will discuss about the fundamental of recursion and why the recursion we are using in the programming, or I can say DSA algo, and like everything I can say from the basic to where we are using, what is the application of the recursion. So just start on that. First of all, we have to know like what is the fundamental of recursion in the programming, and second, I have a question like everyone, like if you are beginner to learning the started learning on the recursion, so you have to be question like what is the meaning of the recursion. So recursion is like basically widely used in the data structure and algorithm to solve the complex problem by breaking them down into the simpler lines. Like I can say that in the small parts we can break it into the big problem and try to solve each one step by step. And like, but basic definition I can say from the recursion, solving problem using the solution of the smaller sub problems. Like recursion, it is like mathematical frequency and where we can find out many example like expression written in terms of like calculating the value of n factorial, and nth Fibonacci number is one of the best example. But recursion is just a match of the programming concept. I can say like if you have better, I can write somewhere. Just not here, but finding the n factorial, like we know in the 12th or 11th, 12th we are heard about this, what is the factorial, how we are calculating. So I'm just asking like what is n factorial. So you have a an image in your mind like n factorial equal to n into n minus 1. So similarly for the Fibonacci series also, like when we are trying out the what is the Fibonacci series, so that means like you are going to solve n minus 1, n minus 2, like that. Okay, so that's a basic example of the recursion I mean to say. And when we heard about this recursion and what is the meaning of the recursion, then after that we have a like question in our mind, how recursion works in a real life. The question every candidate or every person or every student is thinking about that. So suppose like I can say in the real life, suppose you are standing in a long queue of the people, and how many people are directly behind you in the line. So how can we solve this problem recursively? I just giving the example from the real time. So on that scenario, what we can say, we have a rules like on a one person can see only the person standing directly in front and behind. Like you are standing one of the लोग, आप खड़े हुए प्लेस पे और आपके आगे और आपके पीछे कौन है आप उन्हीं को देख सकते हो, not in the entire people from behind side. So that's the like main reason, like leaf type I can say. So it can't like just look back and count. Second, I have the rules like each person is allowed to ask question from the person standing in front or behind. You have to be question, so you can ask the people who is front of you or who is behind to you, not like the fourth or last one person. So this is the like rules I can say in the recursion manner. So for this we have a solution like you look behind and see if there is a person there, or if you're not, you can return the answer is zero. This type of like in the coding point of view I'm telling. So similar type of scenario which we are executing in our problem or in our programming style, we have to be find like if we are getting the value, we are returning the value what we are getting. If not, then we can return the answer zero. So this is the step we can repeat until wait for a response from the person standing behind, like last one I can say. And once a person receive a response, they add one and respond to the person that asked them to person standing in front of them. So this is the similar type of process we do until we reaching the n minus one or last person I can say. And in the programming manner I can say, in the programming terms, recursion is like function calling itself until a base condition is true to produce the correct output. So in other words, like to solve a problem, we solve a problem that is small instance of the same problem and then use the solution to that small instance to solve the original problem. Then after that, the when we are starting to solve the problem, then what the rules or what the idea we keep in our mind while working with the recursion. So I can say first we have to be like our code must cover all the valid instance of the smaller input sizes. As you can see, I already written here. We must have a correct base case that make no recursive call. Third, we can see like when we make a recursive call, it should call a smaller instance and progress toward the base cases. Next, we have correct recursive structure and base cases. then recursion would solve the problem for us. This is the like recursive leap of faith, where we should not worry about the intermediate step or recursive also. This is the like 4 points I can say considering in our mind, or keep in idea in our mind while solving or while working with the recursion. And I can say in the function how we are using the recursion, I can say basic example or best example, I can say recursion in the function manner. Calculate the sum of two number using recursion. So you can see I created one function sum passing two parameter, because I need the sum of the two numbers, so that's why I passing the x and y, that is the two variable of the name which we are trying to add after getting the input from the user. And when we are applying the condition, we are checking when we are getting the value of variable x, then we are checking if y equal to 0, we are getting the x and checking the if y equal to 0, or else we can like give the addition of 1 plus sum, the recursive call again I can say sum of x comma y minus 1, and that is executed until y greater than equal to 0. Similarly, for the product of the two number also using recursion we can solve similar what we are previously do for the addition of the two numbers. Just created the product function and passing the value of variable and checking until it is going to greater than equal to 0. So this is the like using recursion we are creating a function. After this we can say how we are using in an algorithm, and there is also like some of the popular algorithm where we are solving the solution or problem using the recursion. Best example I can say right now in my mind, for the example like reverse an array, you can see there is a reverse an array, one of the problem you can use there also the recursive concept. Then again like finding the Fibonacci series, then like binary search algorithm like that. So this is the type of concept we are using in our using in recursion with the same different function and algorithm. And while implementing the recursion we have to be check like what the mistake we can't perform over there. So like two common way for the recursive implementation maybe go wrong: the base case is missing internally, or the problem need more than one base cases, but not all the base cases are covered. So this is the first problem. Second, the recursive step doesn't reduce to a smaller subproblem, so the recursion doesn't cover it. So like if the problem is not breakable into small subproblems, so there is a no use of recursion applying on this type of problem or this type of scenario. So that's it for this today, and I think if you like or if you get the some idea insightful from this video, please like, share and comment. Thank you.